For the first time, scientists can reconstruct a high-definition video of your moving face directly from your brain activity. This breakthrough dataset and method are changing how we understand perception and consciousness. Let's get into it. Let's start with a featured paper. fMRI-2Face, a full HD fMRI video dataset and geometry-guided neural decoding framework for dynamic human face reconstruction, by Jingyong Hua and Jianfeng Feng from Fudan University. fMRI-2Face provides an unprecedented high-resolution fMRI video dataset and a geometry-guided neural decoding framework, pushing the boundaries of dynamic human face reconstruction from brain activity with significant implications for neuroscience and AI. Here's a full breakdown.
Looking at the left side of the diagram, the fMRI input is first fed into an appearance context predictor. This generates appearance context tokens, which form the brain-derived appearance context to capture the subject's stable visual features. Feeding into the top pathway, the same fMRI input is used by the geometric predictor to create a set of geometric parameters. These parameters then drive a decoder and renderer to produce the rendered facial control, which explicitly guides the facial movements. Next, these two streams are integrated within our neural-controlled video diffusion model at the bottom. Here, a control transformer branch uses the geometry control condition to guide the video diffusion transformer backbone, ultimately generating the reconstructed facial video. The fMRI-2Face method consistently outperforms prior work like MindVideo, NeuroPictor, and MindEye2 across all listed metrics. It shows substantial improvements in metrics, such as FVD and FWE, demonstrating superior performance in dynamic human face reconstruction.
Up next, our second paper out of 3. Transforming Keystroke Noise to Text, Self-Supervised Acoustic Eavesdropping Attacks on Keyboards by Atsunori Okada and Naofumi Homa from Tohoku University. This paper presents a highly novel and impactful self-supervised acoustic attack that demonstrates a significant and previously underestimated security vulnerability with broad real-world implications. Let's break down its key contributions.
First, our system takes the raw audio waveform and runs it through the clustering process shown at the top. This pipeline segments keystrokes, extracts features, and uses clustering to group similar sounds into a discrete series. Feeding into the next stage, this clustering series is interpreted by a transformer-based language model. This BERT prediction block is what initially translates those acoustic clusters into a sequence of characters. Next, to improve accuracy, the system uses an iterative feedback learning process. This loop performs self-supervised training to continuously refine the model's understanding of the keystroke sounds. The graphs display the method's Levenstein score across different devices and communication platforms, without showing a direct comparison to prior work or baselines. However, the method consistently achieves high Levenstein scores, often exceeding 90% for most devices after 200 to 250 keystrokes, indicating strong text reconstruction capabilities.
Up next, our third paper out of 3. PoCEvolve, Generating Proof-of-Concept Exploits from Security Patches with Vulnerability-Aware Prompt Evolution by Duc Man Tran and David Lowe from the University of Sydney. PoCEvolve offers a highly practical and impactful solution for generating proof-of-concept exploits from security patches, significantly aiding defenders in vulnerability assessment and prioritization. Let's break down its key contributions.
Let's start by looking at the overall framework, which is designed in 3 main stages. The process begins with a commit that is passed to a commit analyzer to produce a vulnerability report. Feeding into the core loop, the vulnerability report is used by the exploit generator to synthesize an initial version of the exploit code. This code is then passed to a verifier to check if it's successful. Next, if the attempt is not successful, the system assesses the context from the failure. The verifier provides runtime info and identifies failed prompts, which are then collected for adding feedbacks. This feedback then guides the prompt evolution process, where the prompt evolver refines the failed attempt. It creates a new prompt, which is fed back to the exploit generator to try again, improving the chances of success. PoCEvolve consistently demonstrates substantial improvements in success rate over both the direct LLM baseline and the PoCGN method. For example, with GPT-4o Mini, PoCEvolve achieves a 58.4% success rate, representing a 200% improvement over the LLM baseline and a 20.7% improvement over PoCGN.
Those were the top papers. Now let's zoom out. ArXiv received 461 new computer science papers across 55 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: generating and analyzing complex data, optimizing and securing LLMs, AI for complex system analysis, evolving agents for decision-making, unpacking neural network depth. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.